All right, moving on. Our first speaker is Dr. Scott Loarie, co-director of iNaturalist at the California Academy for the Sciences. Dr. Loarie completed his PhD in environmental science at Duke after studying at Stanford for his undergraduate and master's degrees. His interest in research focus on the application of technology to confront conservation challenges, particularly how land use and climate change impact biodiversity and in ecosystems across the world. Join me in welcoming Dr. Scott Loarie to the stage.
Hey guys, thanks so much. Well, I want to thank Blueprint and Maya and Josh and Sam and everybody for putting this on, inviting me. I spent 4 years out here for up to 2008, and it's really freaking me out that it's been 10 years. So, but it's great to be back. It's really exciting to be here. Yeah, so I've been working pretty much for the last 10 years on this thing called iNaturalist, and I just wanted to talk a little about it because I do think it's a good example of kind of the stuff that that Sam was just talking about. One of the things we really talk a lot about a lot at the Nicholas School is kind of those themes that we're talking about. I mean, one is, man, our ecosystems are unraveling. We have all these environmental challenges, but we just don't have the planet analytics that we need to make good decisions. We don't have the data we need. Wow, that's a big problem. We don't have the data we need at scale, the analysis we need at scale. Second is this green lifestyles. You hear about this nature deficit disorder, right? Kids aren't going outside. We're just completely cut off from the natural world. Wow, that's a big problem. How do we solve that? So what we're trying to do with iNaturalist is really solve those two problems together. Can we do something that really connects people with the natural world, this green lifestyle sort of theme, that also produces the analysis and the data that we need to make good decisions about the environment? And how can we do that? And what can we use to do that? And that brings in the third sort of transformative frontiers, which is let's try technology. Let's try, and specifically social networks, photo sharing. I mean, when I was here at Duke, I was just thinking about it. I didn't have an iPhone, It's just, I guess it was 10 years ago. It feels like yesterday for me. Now all of a sudden we're all carrying around in our pockets this pretty powerful sensor. And so with iNaturalist, we're saying, this really simple activity, which is, we all do it all the time, which is you're outside and you go, oh, that's a neat flower, take a picture of it. Can we turn that really simple, accessible activity into something that solves these two problems, that engages people, connects people back with the natural world, and produces the data that we want to really solve these problems at scale? So that's what we're doing with iNaturalist. The basic use case, you walk outside, you see what's an interesting butterfly, take a picture of it. The app will use computer vision to identify it, and then you can share it and discuss it with a community who vets it, turns it into actually a real research data point, and then that goes into the scientific mind, and we try to then share that that contribution with you, so you sort of see that you're really contributing. But again, it's such a simple activity, but I think what's really exciting about it is what happens at scale. But even from these observations, there's some neat stories. I just wanted to share one anecdote, and we literally get neat stories like this, every week or so. But this is a great story where this tourist was in Vietnam, so he's on vacation in Vietnam, and he sees a snail, and he takes a picture of it and uploads it to iNaturalist. And then there was a scientist, a mycologist who studies snails, a Vietnamese scientist. And he went to iNaturalist and he goes, whoa, I recognize this snail, right? This snail has never been collected. It's never been photographed. It was drawn on the Captain Cook expedition that went around the world. They stopped on this island, drew this snail, and it was lost to science. True story. But it's such a distinctive snail on this little island in Vietnam that this scientist knew it immediately, and they rediscovered this thing. And that's what the power of connecting. The chance of that person who stumbles upon the snail actually knowing what it is essentially zero. But this social network and photo sharing and working together, we could produce this pretty neat scientific result. So we get all these kind of great stories that pop up all the time. But for me, what's really exciting is what happens when we do this at scale. We get thousands of people. So this is just today. So today we had that graph up there, about 2,273 people outside today posting 12,000 observations. And it's pretty low time right now because it's winter. Peaks more in summer. But so we have this real feed of observations that are just things that people are seeing all around the world coming in all the time. I just zoomed into Durham here. So this is that little info window is where we are right now. The airport's right there. So it's kind of the triangle. You got Chapel Hill and Durham and Raleigh there. But again, so this is just iNaturalist activity with all these sort of things popping up all the time of people posting these things. And each of these is an observation. So that's like that person seeing the butterfly. And what we've been trying to do is, can we scale this activity enough that we can really kind of pull the system that I was describing out of here, something that really produces the data and the analysis that we need at scale to really do conservation, but also that really is sort of a transformative social network and community. So we launched this thing 2008, kind of when I left Duke, kind of as a garage project, and we've been slowly doubling every year. And that's another thing that I think people, these things take time and they take grit, and you have to be patient. And iNaturalist, people are like, wow, it's getting, it's getting big, but it's always been just slowly doubling. Going from 2 users to 4 users is the same as going from now we're going, from hundreds of thousands to more, but it's always been that very steady, slow, committed growth. So I just really encourage you guys, like, things start small, but if you keep at them and you have that growth, things get big quickly. This is our community at the moment. So each of those bubbles is scaled by the amount of contributions. So it's cool. It's kind of the classic, like we call it the Wikipedia long tail distribution, where there's lots of people who maybe go to Wikipedia once or edit one article, and then you have these kind of power few that really do a lot of the work, the 80-20 rule. So those big circles in the middle are the people that really kind of are the hardcore iNaturalist users. And that's, oops. That's not what I want to do. I'm in there, but don't worry about that. But again, this is the community, right? But with the value of that community, one of them is that they're engaging each other and they're connecting each other to nature. But another value from a scientific point of view is what's coming out of that. So what's cool is we know there's about 2 million species out there, right? Probably more like 10 million, but 2 million that have names. And that's, everything from little protozoa and kelp and things like that to American robins and things. But we've observed on iNaturalist, we have an observation of about 150,000. So that's not huge in terms of all 2 million species. We've observed 150,000. But it's a significant fraction. If you look at just the vertebrates, of which there's about 70,000, we've observed 1/3 of all vertebrates so far, which is pretty cool. I mean, that includes all bats, thousands of bat species, thousands of rodents that live in tiny little mountains in Colombia, tens of thousands of deep sea fishes. In this little website, we've already observed 1/3 of all mammals. 1/3 of all vertebrates, which is pretty cool. And this little feed right here is, every day we get about 15 new species. So this is what we got today. We got that weird skinky, it's a legless lizard, but 4 hours ago that popped up. We got a couple new fish. We got this beautiful salamander 16 hours ago. So we're slowly ticking away at getting, the tree of life, trying to get all 2 million species. And this is just one person posting one observation. But we can't really do a lot with just one observation, right? What we really want to get is enough data that we can really do interesting analyses. So this is that I mentioned there's 2 million species. So this tail goes out to 2 million species that, we know there's about 2 million out there. And like I said, we've observed about 150,000. This is pretty old, but currently we're about 150,000 species. But a lot of those, we just have one kind of high quality observation. You can't do anything with that. So what we really can do cool stuff with is on this end of the scale, where we actually have hundreds or thousands of observations. So like Jamaican toady, which is a little bird that lives in Jamaica, we only have about 10 observations of that. We can't do much. But then you take grove snail, we've got thousands of them. We can do all sorts of cool stuff. So I just wanted to give 3 examples of kind of the cool stuff that we can do with that data. And the first is that we have a real grassroots, on-the-ground constituency around those species. So these species, we say, wow, a species that we have a lot of data on, we go, these are the people that actually have seen it. We're connected to them. They're in our social network. We can talk to them. We know these are people who actually know how to find this thing in the wild to go check on it. These are people who know how to identify it, which is an extremely useful thing. So like actual groups of iNaturalist users is in Argentina and Madagascar and Chile. And these guys are talking to one another and connected in a social network, which is hugely valuable. A second thing that's kind of cool is we can use all this data to train up machine learning algorithms. So then iNaturalist, you can take it out, and for species that we have a lot of data on, you can take a picture of it and it will automatically identify it. And it works really for species that we have a ton of data on. Like this is black cherry here. We've got thousands and thousands of pictures of black cherry. So you can take a picture of the bark and it will identify it to species, which is pretty cool. I was actually with a botanist in this, and he was kind of testing, and he's like, well, it's not going to work on that. It's, And we hit this sedge. And he goes, it's not going to work on that. That looks just like grass. And it actually got it. It's a sedge, but it's a common sedge in the East Coast. We have thousands of observations of it, and it works really well. So again, it's a question of can we get this platform to get enough data on enough of these species to do this cool stuff, like build these communities, do the image recognition. And the thing that we're really working on now is to actually model the distribution of these things in space and time, so we can actually do real conservation. So this is a American trout lily, which is common here. Do you guys know this plant? is a common little flower that it grows all over the Duke Forest here. It's like a little yellow flower. Sorry, I just came off a red eye. I think I'm getting a little red eye on myself. So this thing blooms every year around April, right? And that's just 1 month of the stuff here. But when I'm going to play a little animation here, and you'll see the bloom of this thing going up the East Coast. I'm going to click the mouse here. So see it go like that, which is kind of cool. And let me play it one more time. So that's just 1 year of data. And that's not a model. That's just raw data. So we have enough data of this one plant that we can actually see the whole life history of the thing, that actually blooms like this. And we can see that from year to year. It changes. So we can see, for example, for this species, that it's bloomed about 3 weeks later. 3 weeks earlier, the last 2 years, 2016, 2017, than it bloomed the 2 years before that, which is pretty cool. And this is what everybody's been seeing. Spring feels a little early this year. But we actually have real hard data to show this. And again, we can do this now for tens of thousands of species. But can we get a system that can do this for millions of species? That's the goal. And we're not just getting the actual distribution of the thing. We're getting life history. This is a moth. So this moth, people go out and observe the moth, but we're not just identifying what moth species it is. We're identifying whether it's a caterpillar or whether it's an adult. So this orange graph here is the adult, and then the blue is the larva. So you can see the whole life history of this moth. The adults emerge around May, and then they lay their eggs, and the caterpillars emerge, and then the caterpillars overwinter as caterpillars for the summer. You see the entire life history, and we can see that's changing. All of a sudden, whoa, the larvae are emerging earlier. We get the complete picture from this thing, and it's just emerging from all these people going outside and taking pictures of moths. And we can do really cool modeling. Like, for example, once we have enough observations, this is American pica. We can say, this is where we predict this thing is now and what's going to happen if we do 2-degree warming and things like that, and kind of play with modeling all this stuff. So that's what we can do now. But again, our goal is to be able to do this for tens of thousands, hundreds of thousands of species, millions of species every year. And to do that, we really need a lot more data. So if we can keep this doubling that we've been doing for the last 10 years for another 3 years, that's our goal. We get to the International Year of Biodiversity 2020, and we'll have a system that can really produce, millions and millions of observations every year, which is going to be what we need. And that's not, that's just maintaining what we've been doing in the past. So that's our goal, is to keep doing that. And first, to do that, we need to continue to grow our organization. So again, we've kind of gone from this sort of independent garage thing. We've been at the California Academy of Sciences for the last 3 years. Now we have a great partnership with National Geographic and also Microsoft, which is great. And we're trying to do a lot to sort of make sure that we can maintain that growth rate. But one of the things that's really interesting is the spatial distribution of this is most of the activity of iNaturalist in the past has been in North America and Europe, because that's where people are doing this. But this is where our growth is. This is actually a little old. This was 1 million observations ago, but this was the million observations that we got over the summer. And you see, even though we have tons of observations from North America, we're not getting a lot of growth there. We're getting a lot of growth in Canada, we're getting a lot of growth in Australia, a lot of growth in Europe. And this is actually our last million observations that we just got kind of around the last 2 months. That was mostly in South Africa and Australia, because that's their summer right now. It's American winter up here. But we're getting huge growth in South America and South Africa. So this is a sort of a distribution of the countries. We've got a lot coming from the United States, a lot from Mexico, a lot from Canada, a lot from New Zealand, Australia. But what we're really focusing on now are these countries that are underrepresented. So for example, if you look at this map, we've got tons of observations from North America and Europe. But what's going on in the Amazon? What's going on in Africa? What's going on in parts of Asia? And this is where, for me, it kind of really gets into some of the conservation technology, because a lot of the focus of this conference is talking about gizmos and gadgets. We're kind of cheating with iNaturalist. We're just using an iPhone that everybody has in their pockets. But if you say, how do we get people doing this in sub-Saharan Africa, where maybe people don't have access to smartphones yet? Is there some sort of gizmo that they could make to do this? Or is there some sort of thing we could do to overcome these challenges in terms of bandwidth and things like that? And we just got a grant from JRS to do fisheries monitoring with iNaturalist in the Okavango Delta. And it's really exciting, but man, that's a place where there's no connectivity, there's no access to technology, the fishermen do not have cell phones. And so I'm really excited at this workshop to talk about, how could we sort of get people across the world doing this, even when there are access to technology issues. Something I'm really excited about. Anyway, thanks a lot, I really appreciate it.